All right, so today we are going to be going through the use of this microscope. You also had a chance to look at one on your pre-lab, right? It's called the compound microscope, remember? So why is it called the compound scope? Do you remember?
Two different types of lenses.
Two lenses, right? Two things working together, just like the idea of a compound substance. When you've got two parts working together, we have two sets of lenses. The lenses that you look through up here, and the lenses that point down to the object that you want to investigate or look at. Those two lenses work together to give you the magnification or the image that you want to see. Okay, so before we get to that though, we're going to go through various parts of the microscope so you know what they're all called and how they all function. So the first thing we're going to do is everyone's going to get a microscope of their own to play with, or to use, not play with. So the scopes are in the two cabinets on the back wall behind Xavier. When you pick your microscope up, there are ways to carry them. Okay, they will have a cord at the back. It should be tangled up like this or wrapped up. If it's not, watch out for it because you can always trip over it. So make sure you're aware of where the cord is. And when you pick the scope up, there's like a hole here to hold it through and underneath. So you carry it back to your bench like this, all right? You do not hold on to this part because this top part, although it might be tempting to hold on to it, actually moves around and will completely lift off if it's too loose, causing the rest of it to crash dramatically to the ground, which we don't want to happen. So when you carry your scope, support the side and the bottom and bring it back to your table. When you've got your microscope, go ahead and unwrap the cord and plug it into one of the outlets and then just wait for everyone to catch up with you. The scopes are in there by cubbies, so you can look at your number and get the number that relates to your microscope. If you can't reach to the top, see if you can have someone else help you out to grab it who's taller. So don't be teetering with this head because they're pretty heavy and they're pretty expensive, okay? And so's your head. So we don't want one to hit the other, all right? Okay, go find a scope and I'll meet you back at your tables. All right, so once everyone has got a microscope, go ahead and plug it in, and then how you place it on the table is totally up to you. Everyone is a different height, different layout, so some people like to push it further back, some people like it right here. It just depends on what's comfortable for you. You might have to range just the height of your seat as well, or you might even have to stand up. It just depends on what is going to work for each different person. You'll get used to it as we go through today, because we're going to be staring down these things for 2 hours, so by the end you'll be used to it. Okay, so let's go through some of these parts. First of all, we have the base of the microscope, which is what it's sitting on, and then we have the arm, and that's this piece here, that it's all the fancy stuff is attached to. So the base and the arm of the microscope. All right, so those should be both on your diagram. And if you look at the bottom of the base, on the right-hand side, there's a toggle switch, and you can go ahead and switch the microscope on by flipping that switch on the bottom right side of the base. And then in front, just slide in front of that switch, there's a dial. So let's not look through the scope yet, because we'll get headaches at this point. Let's just mess with this dial and see what it does. So turn this dial around on the base and tell me what it's doing.
Adjusting brightness.
Right, it is adjusting the brightness of the light that comes up from underneath, right? Okay, the next thing we're going to look at are these two dials on the where the base and the arm join. So at the bottom here of the scope, there's a fat dial and then there's a skinny one sort of inside of it. Now we're not going to look through again, we're just going to turn the big dial and see what it does. So when you turn that big dial, what does it do?
Lifts the stage up and down.
It raises this platform right up and down. Everyone got that? Able to move the platform up and down? This is what we call the coarse focus, and it allows us to bring our specimens into focus by changing the position they are from the lens. Okay, the coarse focus, that's C-O-A-R-S-E, like rough, coarse, not like C-O-U-R-S-E, that's this is a biology course, all right? So the coarse focus raises and lowers the platform here, which is called the stage. We'll get to that in just a second. So inside of the coarse focus control, there is a skinny dial. Go ahead and move that one and see if you can see anything change. Anything happening? No, it doesn't look very dramatic. Definitely not as dramatic as moving the coarse focus, right? But this one is called the fine focus, F-I-N-E, fine focus, and it is moving the platform up and down, just such tiny, tiny amounts that you can't detect it with your naked eye. But when you look through the microscope, you'll see a difference. So this is moving the platform up big chunks at a time. This one's moving the platform up and down little tiny bits at a time, just to fine tune it. So we have the coarse focus control and the fine focus control. All right? So today we're going to drop the stage all the way to the bottom. So use the coarse focus to move all the stage all the way down until you hear this kind of little chunk. Don't force it beyond that. It'll just sit there. That's the stage lowered. So we have the light on bright and we have the stage lowered. Next, we're going to focus on the stage. So the thing I've been calling the platform officially is called the stage. It's where you put what you watch, like stage production. So this is our stage. And then let's look underneath the stage. So if you look under the stage, there's a whole bunch of complicated looking stuff stuck there. So first of all, this whole bunch of stuff is called the condenser. The condenser. So that's a C-O-N-D-E-N-S-O-R or S-E-R, the condenser. And the light comes from underneath up through the condenser into your specimen. Now if you look on the back left side of the condenser, you'll see like a little fine knob that comes out that's got ridges on it. So on the back left side. Go ahead and turn that and see what you can make it do. So when you move that knob, what happens?
It moves the condenser up and down.
Right, thanks, Janai. It's dropping the condenser down, or you can dial it back up. Everyone got that? So that's the that control moves the condenser. Today we're going to have the condenser raised all the way up so that it's flush with the stage. All right. If you look on the front of the condenser, you'll see some numbers: 4, 10, 40x. Looks like kind of like a camera lens. So go ahead and this time look down through the circle of light through the stage, not through the lenses, but actually at the circle of light directly, and move that dial around, and tell me what happens.
Increases or decreases how much light comes through the condenser.
Right, it's increasing or decreasing the amount of light that's coming up from underneath. And what this is, it's called the iris diaphragm. The iris diaphragm, that's in your book in number 10. It's like the iris of your eye, which can contract down or open up to let less light through or more light through. So when it's all the way rolled counterclockwise, it's letting no light through. When you roll it all the way clockwise, it lets maximum amount of light through. Okay? So to start with today, we're going to have it all the way open, just to make it bright, to make it easy. But as you go through today, you can dial this back to control the light to make yourself able to see more details and things. So that's your iris diaphragm. So right now we have light on, stage dropped, condenser raised, iris diaphragm open. Okay? So these are the steps that you need to go through whenever you set up a microscope. It doesn't matter what you're planning on looking at or what the scope is, you always set it up the same way. Turn the light on, drop the stage, raise the condenser, and open the light. Those are the same. It doesn't matter if you think you know what you're doing. It doesn't matter if you think you know where it has to be focused. Always start with those same steps. Okay, so now looking at the top of the stage, you can see some silver metal pieces on it. On the left side, there's like a little flipper, looks like a pinball machine thing. All right, you can press that. That opens up to allow you to put your specimen in. And then you kind of push it back so it just sort of holds it in place. On the rear, the back right side, below the stage, you see some knobs hanging down. Go ahead and move those around. They're sort of dangling off the side of the stage. What happens when you move those?
Forward and backwards.
Yeah, you're gliding this whole thing on top, backwards and forwards, and also left and right. So the top one goes forwards and backwards, the bottom one moves left and right. This is called the mechanical stage. So the flat piece is the stage, and this is the mechanical stage. And this allows you to move your specimen around as you look at it, so you can sort of scan across it, scan through it. So the stage, the mechanical stage, and this is how you control the mechanical stage. All right? That's basically the bottom half of the scope. The business end is the top half, though, with all the lenses. So let's get to that next. So we've got two lots of lenses on the microscope. The ones that our eyes look through, and the ones that point at the specimen. So do you remember from the pre-lab what these are called?
Oculars.
Oculars, right? The ones that you look through are called the ocular lenses, and the ones that point at the thing, the object, are the objectives, right? The objectives point at the object. That's how it's easy to remember. So oculars and objectives. So first of all, the oculars. Now it's going to be bright, but go ahead and look through the oculars. And you should see, when you look through the oculars, a single round circle of white light. All right, now, you may not be seeing that. You may be seeing like sort of two that are kind of crossed over, or all kinds of weird stuff. That's probably because these are not set for your eyes. You can move these. They flap like the wings of a bird, see? Everybody has eyeballs different distances apart. So if you look through them, you can modify the distance until you see one single circle of light. If you go too wide, you'll start seeing two separates. And if you go too close, you'll start seeing all kinds of weird things. So just pull them so that you can see one circle of light. All right, now it's going to take some getting used to. And we'll talk about why that is next. If you wear glasses, you can try with glasses on or glasses off, whichever works best for you. Different people like it different ways. And you may also have rubber rings around your oculus. Some of the scopes have these, some do not. So if you have rubber rings, you can actually kind of press your eyes like actually up against the rubber rings. Sometimes people find that's helpful to block out the light on the outside. Or you can fold the rings back, like I'm doing on this one, and that makes it flat. And then you can just kind of hover your face at a distance that works. But again, this is a skill. You're just going to have to practice and get used to it. All right? So when you look through the microscope, you probably can see a little ruler in there and also some crosshairs. You guys see that in there? And one should be on top of the other. That's what it's superimposed, right? So everyone's seeing that? Yeah? Yes. I'm assuming quiet, so yes. So what I'd like you to do is close your right eye and look with your left eye only. And then close your left eye and look with your right eye only. What does that tell you when you do that? What do you see with just your left eye? Just the ruler. What do you see with just the right eye?
The crosshair.
Just the crosshairs. When you use them both together, what do you see?
Both.
You should see them both. But this is what's happening here is that the crosshairs and the ruler are actually inside these lenses. The ruler's inside this one, the crosshairs inside that one. And so when you use both eyes together, your brain is getting an image from this eye which has a ruler and an image from this eye which has a crosshair. But when you use both the eyes together, your brain is trying to put the images together to make one image, and so one seems to be on top of the other. But your brain is fighting that right now. That is weird. Your brain's like, what am I looking at? I'm seeing two. So usually when you look at the world, your left eye sees this, and your right eye sees that, and that both goes to your brain, and your brain takes the overlap and stitches it together, so I get a panorama. And my brain is using the image that is common to both eyes to create the stitching and create my field of view, right? But when I look down here, there's no overlap. This has the ruler and nothing else, and this has the crosshairs and nothing else, and my brain's like, what do I stitch? There's nothing that's equal. I don't know how they overlap. So it's really struggling with putting them together. And you're having to train your brain to say, it's okay, they belong together, just put them over each other. But you probably have one eye that's much more dominant than the other. All right? And so one eye is saying, no, it's the crosshair. or one eye saying, no, 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 it's the ruler. And so the brain keeps separating the images and then putting them back together, and you're trying to kind of get used to it. To tell which eye you have dominant, you can figure that out pretty easily. If you take a finger, so look at something in the distance, like the clock or the exit sign on the doors. If you look at that, and then hold your finger out and put it in front of the exit sign, or the clock, or whatever you're looking at. And then close one eye, the finger will stay in place. Close the other eye, and the finger will jump off to one side. All right? Whoa. All right? So where it stays in place, that's your dominant eye, and where it jumps off, that's your eye that isn't quite so dominant. Now, some people have completely equalized, then neither dominant. Some people who've done a lot of shooting, if you do a lot of shooting, you're used to training your eyes to like look through a scope and look through a sight. And so I find that people that have been in the military are good at this. They can figure it out. But for the rest of us, it's just time. You just got to train your brain to accept that this is the same image and it has to overlap it, but it's going to swim apart from time to time and it's going to make you feel a little dizzy. That's normal. So it just is what it is until you get used to using the scope. Okay? All right, so those are our objective lenses. Sorry, the ocular lenses. Next we have the, one more thing about the objectives. If you look at them, they have a magnification. So these are a power of 10x. So just on their own, these are already magnifying things 10 times. All right? But we are also not just using these on their own, we're also putting the image through these ones too. So the objective lenses are down here. They're the ones that look like these little noses that point out. And we have 4 of them on this scope. So you can move them around. If you hold the rubber ring up here at the top of the objectives and you can twist it either way, you can feel them click around into positions. When they click, you can see the one that's pointing down. All right? So our 4 magnifications on these microscopes are 4x, which is our red lens, 10x, which is our yellow lens, 40x, which is the blue one, and then 100x, which is the white one. All right, those are our 4 magnifications. However, in 181, we are not going to use the white lens. We're not going to go near the 100x. Okay, we're just going to use the red, the yellow, and the blue. And everybody always gets this, oh, the 100x is so cool. It's really not cool at all. It's horrible. It's really, really, really hard to use. You have to use it with drops of oil. It really messes up the microscope. When you take microbiology, all you'll use is the white lens, and you'll wish you were back in 181, where you didn't have to use it. So we're just going to leave that one be, and we're just going to work on the red and the yellow and the blue one today. We're going to go ahead and put the red lens in place, which is the lowest power. So the red lens is the 4x power. It's also called the scanning power, right? So we're almost ready to look at something. So let's check again. Light is on, turned up. Stage is dropped. Condenser is raised. Iris diaphragm is open. And our red scanning lens is in place. You always start with that red scanning lens. It doesn't matter what you're looking at, always start with the red one. Okay. And you make sure that you've got your single circle, that this is positioned correctly. All right, and what we're going to look at today is fleas. These are dog fleas. All right. So I'm going to go ahead and give each person a flea on a slide. They're dead. So you're going to take the slide. You'll open your pinball flipper thing. You're going to place the slide in the corner of the mechanical silver holder. Place the flipper back. And then use the mechanical stage control. We're not going to look through this because this will drive you crazy. Trying to search for the flea is like looking for a needle in a haystack. So we're just going to use our eyeballs to put the flea above the circle of light like that. So I didn't use the scope, I just positioned it using my naked eye. Okay, so your chance to get your flea on the stage in the jaws. It doesn't have to be crammed or jammed underneath anything. It just kind of just rests on the top of this surface, and so that it can glide around when you move it like this. All right, has everyone got their flea in the circle of light? Okay, so what we're going to do now is look through the scope and use the coarse focus to gradually raise the stage up And as you do that, the flea, if you've got it in the middle, should magically appear before your very eyes. Okay, so let's see if we can make it work. So once you've got your flea in position and you're looking at him, you can try moving him around a bit. So use the mechanical stage and see how it makes him shimmy up and down and back and left and right. And the other thing we can do now is focus the microscope for our unique eyes. You probably have different eyes, and if you ever go to the opticians, you don't get the same prescription for both eyeball. So you can adjust for that on these microscopes. And it's a good idea to do that, because if you don't, after using it for a long time, you'll get a headache. So what you want to do is close your left eye. If you can't close it, just use a hand over it. And use the fine focus to focus the flea, one part of the flea, pick a part, like one of his hairs or his mouth or his eyeball. Look at that and get that super crisp in focus using the fine focus only and your right eye. So we're going to use our right eye and make one part of the flea really sharp. Okay, once you've got that, you're going to close the right eye, and this time do not touch the focusing knobs. Stay way away from them. Up here on the actual ocular itself, there's a ridge bit. You can twist this ocular. So we're going to use our left eye, look down, and focus the exact same part of the flea. So look at the same portion. If you were looking at a hair, look at the same hair, and get it really crisp for your left eye using the ocular. And once you've done that, you can open both your eyes again, and it should be in perfect focus for both eyeballs. And now you've set that difference, it's going to be good for the whole day. And once you've done that, you can open both your eyes again, and it should be in perfect focus for both eyeballs. And now you've set that difference, it's going to be good for the whole day. You don't have to change that again for each slide you look at. Once you've set that up, this is going to be your scope for the rest of the day. You don't have to readjust it. Go ahead and crank your microscope around to the next level of magnification. So we're going to move the nose piece, which way is that, counterclockwise, and click in the yellow lens, which is the 10 times lens. And now you can look down, and it may be blurry. You can use the fine focus to bring it back into focus. And now you'll definitely need to use the mechanical stage, because you won't be able to see the whole flea at once. It'll be so big that you're going to have to, if you want to see its butt, it's going to be over here. You're going to have to move over here to see its head. One last magnification. We can increase up to the blue lens. Now, flip around to the blue lens and just stand back and look at the slide in the lens for a second. So when you have that blue lens in place, what can you tell me about it and the slide?
There's like no distance between.
Really, really close together, right? Really close. So this is a very important item here. You get your specimen in focus roughly the right place by using the red lens. That's why you always start with that red lens. Then as you go up, all you need to use to tweak the focus, is use the fine focus. You never touch the coarse focus using the yellow, and especially not using the blue lens. Because what would happen if I go ahead and use the coarse focus right now?
Crack goes the.
Yes. I'm going to move that stage up a lot, or maybe move it down, but I'll move it up, and I'm going to crunch those two together. There's very little clearance between the slide and the lens. And so when those two things come together, the best case scenario is that you're going to crack the slide. Those are a couple bucks. That's okay. The worst case scenario is that you scratch the lens up inside that blue lens, and these are like thousands. So, and we can't unscratch them. So when we're this close, we only ever use the fine focus just to kind of dial in our crisp image. Never crank that big dial, because that's a big problem. So, and you can see at this magnification for a flea, it's like overkill. It's so close in that you can hardly see anything, right? The flea's just too big. Okay, and there's one more thing I just want to go through on the board real quick. So let's swivel up front here. So we have two sets of lenses on the scope. We have the ocular lenses and we have the objective lens. And we have what we call the total magnification. So our ocular lenses are the ones that are up in the top part of the scope, and we can't change them. They're always 10 times power. So it doesn't matter what we're looking through, the ocular lenses are always 10x. The objectives, we have the 4x, we have which is the red one, the 10x, which is the blue one, and we have the 40x, which is the
10x is the yellow one.
did I switch them around? Okay, this is the yellow, this is the blue, sorry. The total magnification is actually this multiplied by this because you're using them both together. So you've got some of this multiplied by 10 and then you multiply it by 4 times more. The total magnification is actually 40. So when you're using that red lens, you're not just getting 4 times, you're actually getting 40 times real life. Because you've also got the 10 in the oculars that you kind of forgot about. That's the same for all these. We look through the oculars for all these. So this gives you 40 times total magnification. This gives you 10 times 10, so 100 times magnification. And this gives you 10 times 40, so 400 times total magnification. So when you have quizzes and questions about microscopes, make sure you get right what the question is asking you. If it's asking you for what what objective you're using, you would say this. If it's asking you what is your total magnification, you're going to say whichever one of these is correct, right? And I think also in the lab book it does give these names. It calls this one the scanning lens. It calls this one the low power, and this one the high power, right? Last thing, how to put the microscope away. So 3 simple rules. Number 1, always drop the stage. Number 2, take the slide off. You'd think that would be obvious, but the number of times I go over there and there's a crusty old nasty slide on the microscope is surprising. So drop the stage, take the slide off, and then make sure that you wrap the cord so that the next person that grabs it isn't going to end up tripping over it when they pull it out of the cabinet. Okay, and then replace it in your cabinet that it's supposed to go in. All right, so those are the 3 things. Drop the stage, remove the slide, and wrap the cord. Okay, so any questions about the microscope functioning at this point? Everyone feel they're pretty confident about putting stuff on the scope? All right, excellent. All right, thanks. So, any questions about functioning and using the microscope at this point? Yes?
Is it okay if you can only focus one eye at a time?
Yes. If that's something that you're working with, you'll get better at it as you go. So yes. The goal is to have both eyes working so you don't get eye strain. But right now, if your eyes are like really, your brain is really rebelling, then you can do one at a time, for sure. So Janai's having a problem here. It's not turning on. There's several things that it can be. But the usual thing is that the plug in the back isn't in right. So you can make sure it's in really nice and tight. And now try switching it on at the side and turning the dial. Oh, no, still no joy. Is it plugged in good? Oh. Did it go? Okay, that was loose then. That was the problem. So the problem with this one was that it wasn't in tight like that.